So in this video I'm going to show you how to calculate the basic probability measures, especially using the contingency table. So they would give you a cross tabulation like this, whereby you have one category on the side and the other category on your columns. Okay, so as you see here, we have our sample is 146, our n is 146. Let's go through the questions. So the first question wants the probability of selecting male, that is the marginal probability. So the probability of selecting male, you would go to the total for male, which is 82, right? And then the total for the sample, which is 146. So the probability for finding a candidate who is male would be 82 over 146. And please round off to 4 decimal places for probability. 82 over 146 is 0.5616, which when you interpret it to percentage is 56.16% when you multiply the probability by 100. So the second question says, calculate the probability of selecting somebody who prefers Simba. Again, we have a marginal probability because they are asking you to calculate the probability of just one event, single event. So for Simba, as we can see, the total for Simba is 51. The total for the sample is 146. So the probability of somebody that they prefer Simba is 51 over 146. Okay, so this is 0.3493. Again, that would be 34.93%. And now the third question says, calculate the probability of selecting somebody who is male or prefers Simba. Right, so now this is the union of two events. They are saying the event Simba or male. So this is how you write it, is the unions. Probability of Simba union male. So here they are asking you to find the union of two non-mutually exclusive events. So as you can see, Simba and male are in different categories. Male is on this category and Simba is on the other category. That is how we know that they are non-mutually exclusive. Male and female are mutually exclusive. Go Slow, Doritos and Simba, of course they are mutually exclusive. But everything that is in the table is non-mutually exclusive because those events can happen at the same time. They do have an intersection. So the probability of Simba union male would therefore be the probability of Simba plus probability of being male minus probability of Simba and male. Right? I explained that this is because they are non-mutually exclusive. It means we have to subtract the intersection. Okay, I would show you calculating these and then why we are subtracting the intersection. So as you can see, the first probability of loving Simba, of preferring Simba, we already found above. It's 51 over 146. And then the probability of male, we found that it's 82 over 146. And then the intersection of male and Simba is 28 over 146. So that is the part we're going to subtract. Now let's proceed with what we have written here. So from here, the probability of Simba said is 51 over 146 plus the probability of being male, it's 82 over 146, right, minus the intersection. The intersection, you get it that it's male and it's Simba, so the meet here is 28, right? It's 28 over 146. So your denominator is the same. You know, you can write this as 51 plus 82 minus 28 all over 146. This is 0.7191, which translates into 71.91%. So just to re-explain to those who don't understand why we subtracted the intersection of 26. As you can see, this 51 is given by 28 plus 23, right? It's 28 plus 23 gives us this 51. And then this 82, as you can see again, it's 20 plus 34 plus 28. That is what gives us 52. As you can see, we include the 28 twice. We include it for male, it's in this 82. And again, this 28 is in this 51. So that means there's a double counting of the 28. The intersection is counted twice, which is why we are subtracting 28 when we are calculating the union for non-mutually exclusive events. Okay. So moving on to the third question. Oh, the fourth question. So the fourth question says, what is the probability that somebody prefers Simba and is male? The intersection of Simba and male. So you can see the intersection of Simba and male, we have already figured that is 28. That is 28 divided by 146. So that is 28 over 146. Then the question after that is the conditional probability. So how you see conditional probability is that the question like here would say, what is the probability that the consumer prefers event A given B? In this case, they say, what is the probability that the consumer or the student prefers Simba given that he is male, right? The condition is being male. Okay, so it's the probability that they prefer Simba given that he is male. So in this case, it's going to be the probability of male and Simba divided by the probability of male. So just to explain using the table, as you can see, they have given you that this student is male. So we know for sure you don't have to consider any other category. We know that it's male. So we're going to look at this column. We're focusing on this column. And we want the probability that it's Simba, right? So our probability is going to be 28 divided by 82. So that is 28 over 82. So just to retranslate this using the equation, as you can see, probability of male and Simba would be given by 28 over 146, right? Then the probability of male would be 82 over 146. So it would be like this: 28 over 146 divided by 82 over 146. So these would cancel out and you'd be left with 28 over 82. Again, that's because they've given you the condition that it's male, so that's why you would have to only to consider that 82. Okay. Again, the question after that. So I've realized that people confuse between the two kinds of the conditional probabilities. The one I just shown you, I use the total of 82. Some people will ask me, why do you not use the 51, right, which is Simba? But no, the question is asking what is the probability that they prefer Simba given that is male, which is why I used the total for male. But the next question will show you the situation whereby we use this 51 instead. That would be when they have given you that the preference is Simba instead, meaning you can ignore the two other categories and focus on the Simba because it's given that it's definitely that event. Okay, so in that case, then it would be the probability that this male, given that they prefer Simba. Okay. So is the probability that it's male given that they prefer Simba. So it will be the probability of male and Simba divided by the probability of being male. So that would be given by a probability. They've given you that it's Simba. So the probability of male and Simba would be this 28 divided by 51. Again, it's similar to the one I showed you on the question above, that it's 28 over 146, which is the probability of male and Simba. Then the probability of being male is 51 over 146. Then these two would cancel out and you'd eventually get that answer. So that is how you see I've intentionally used the same categories which are male and Simba so that you see the difference on when you use all the different equations. That here it's the marginal is just one, it's just one. This is the union, you see it by when they say or. This is the intersection, you see when they say and. And on the union again, they could say either, then you know that is definitely the union, it's or. And then for the conditional probability, they can say given that or suppose that, then they give you the condition. That's how you see the difference in these different probabilities. Okay, thank you. In the next video, I'm going to show you how to draw the tree diagram for the probability. Thank you.